Hi, in this video I want to talk about Euclidean geometry. And the Euclidean geometry deals with space and shape using a system of logical deductions. It's also known as that part of maths where you need a lot of justification or reasons for everything that you do. But luckily for the NBTs, you only need to understand those theorems in order for you to apply them and get the answer, because you do not get any marks for the logical steps or for your reasons. So we're going to start off with the first theorem, which states that a line from the center is a perpendicular bisector of a chord. Meaning, if I have a line that passes through my center O, and that line bisects a chord, it means it also cuts that chord perpendicularly. So this is the first law: line from the center, perpendicular bisector of a chord. So given that you have a line and it cuts through a chord into equal parts, you can then conclude that it's cutting it perpendicularly. That is theorem number 1. Then theorem number 2 states that diameter subtends 90 degrees at the circumference. So if we have a center O and then we have any line passing through center O like that, and that line, also called the diameter, creates an angle at the circumference, that angle will always be 90 degrees. This law is also known as the angle within a semicircle. So that will always be 90 degrees. Then we can move on to the third theorem, which states that the angle between a tangent and a chord. So the angle between a tangent and a chord, if I draw a tangent, it is likely to look like this. So a tangent is just a line that cuts your chord at a specific position, or at one specific position. So it doesn't cut it more than twice, only once. And we can have a chord maybe looking like that, and then this chord subtending an angle at the circumference. The law says that this angle that is in between our tangent and our chord is equal to the angle subtended. To subtend means to form an angle. So this chord here subtends an angle at the circumference, which will also be x. And that is theorem number 3. Then we can take a look at theorem number 4. Theorem number 4 states that if we have a tangent, so it touches our graph at one specific point, and then we have a line from the center, so a line that passes through our center, it can then be a given that the point where that line and the tangent meet is going to be a 90-degree angle, like that. So that's our theorem number 4. Then we can move on to theorem number 5, which states that the angle that is subtended at the center, so formed at the center, this angle here will be twice the size of the angle subtended at the circumference. Meaning, if this is x, this will be 2x. So that's theorem number 5. Then we move on to theorem number 6, which states that equal chords like that. Maybe let me draw that in a different color, since we're going to draw a chord that is equal to this one on the other side. So an equal chord like that. Equal chords subtend equal angles at the circumference. That is the last law. Therefore, if this is equal to that, that means the angles that they form, being x and x, will also be equal to each other. So these are the 6 laws that govern Euclidean geometry, and you should be comfortable with each of these laws. Given any type of situation, you should know which one to apply, and it's always sometimes a bit of a trial and error. But that's it for the 6 laws of Euclidean geometry.